Hello, today we're going to do maximum subsequence score. You are given two integer arrays, nums1 and nums2 of equal length, and a positive integer k. You must choose a subsequence of indices of length k. For the chosen indices, your score is defined as the sum of the selected elements from 1 multiplied by the minimum of the selected elements from 2. It can be defined simply as sum of 1 times min of 2. Return the maximum possible score. A subsequence of indices of an array is a set that can be derived from the set 0 to n minus 1. Okay, so Python max heap queue. Every parent node has a value less than or equal to any of its children. Right, it's a min heap. So, the way we're gonna handle this let's see. Okay, our constraints, num's length is equal to nums2, n is up to 100,000, nums I and nums2 I is up to 100,000, and k is up to the length of n. Okay, so that k part makes this really easy, I think. If we have 1, 2, 3, 4, 5, and another one, 3, 2, 1, 5, 4. And then we have a k of, let's say, 3. Then we're going to do a length of 3. And get whatever that is. Then we'll do the next length of 3. And the next length of 3. And then we'll be done. We don't have to do 2 pointers or anything like that. We're just going to check every subsequence, and we're going to put those results in a heap. Okay. And then we take whatever the minimum is. So nums1 len equals nums2 len. Edge cases. Can't think of any. So over here, first let's do from heap queue import heapify. No, I think I need heap queue. And then, is that how we do it? Let's Python from heap_q import heap_q. No. Import heap_q. To create it, use a list. Initialize. Oh, so I just do L equals empty and then L dot heap push heap_q dot heap push L1 and then L. Okay. It pops the smallest item in the heap always. So what we're going to do is inverted top score equals empty list. Okay. Just call it top score. And then we'll go for, no, let's start with I equals 0 while I in range length of nums1 minus, actually let's do this another way. First we want to sum up the first k integers. So we're going to do I equals 0 and sum of 1 equals 0, min of 2 equals equals float infinity. And then while I is less than the length of nums1 minus k, actually while I is less than k, we'll finish up with I plus equals 1, and we're going to do sum of 1 plus equals nums1 I. So we're going to start off by just building the first sublist, subarray, and min of 2 equals min of 2 if min of 2 greater than or equal to nums2 I, else nums2 I. Okay, so first thing we'll do is build up sum of 1 and min of 2 based on the initial substring. And then we'll go, then we want to add that to the heap. So top score, heap q is h dot heap push top score, comma, sum of 1 times min of 2. Okay, then we're going to check the rest of the substrings, which is while I is less than the length of nums1 minus k, wait a minute, I is at the end of the substring right now, so we'll just do that. And then sum of 1 plus equals nums I minus nums I minus k. So we add the next one, subtract the first one, and then min let's see, we need to find out if the first one is the min, this is a problem. How do I keep track of the min at each point? Maybe I just need to do min of 2. Actually, at this point I'm fine. From here, let's go min of 2 equals the min of nums2 I minus k time plus 1. I think that's it. Okay, and then after I've done that, I do another heap push. H dot heap push top score sum of 1 min of 2 and then once I get to the end I'm gonna return, oh wait, at each time I do this I want to negative the result. That way the min score or the max score is on the top of the heap, and then when I return I'll negative the return. H dot heap pop top score comma, that's it, top score, heap pop heap, yeah, okay, see how that goes. Runtime error. Nums is not defined. That was supposed to be nums1 and nums2. Got it. Bad operand for unary. Okay. -1 times I guess I don't need that. This is all commutative. And here we have -1 times. Okay. I forgot a +1, didn't I? Yep. I plus equals 1. Inf is not a valid return. Okay, min of 2 did not get reset. If min of 2 less than or equal to, yeah, I had my greater than sign backwards. Okay, this came out wrong. So let's go print top score. Run. Let's see here. Got a -7 and a -8. So k is 3. That means 1, 3, 3. That's 7 times 1. Got it. And then 3, 3, 12. How did I get an 8 in this case? How did they get a 12? Let's see. 2, 3, 4. This is any substring, not just the... Okay. Okay, so I have to get the permutation of the digits. Okay. In that case, I need to figure out a way to find the permutations. I would rather not iterate over the whole slice every change. So I need to figure out if there's a way I can do that, and I'll be back shortly. Alright, I wasn't able to find a satisfactory way to handle this short of build the list of indices, calculate the list completely, and then find the sum and the min. But I did find that itertools creates a combination which finds all the combinatorials. That way I don't have to do multiple loops. I can just give me the combinations and I'll loop over those, and that gave me my solution. So then let's check this against the full test suite, and hopefully I don't get TLE'd. Although this is taking quite a while. TLE. Okay. That's not good enough apparently. Oh, okay. Well, I may have to throw in the towel on this one and phone a friend. But you can see the essence of the solution. It works in theory. Just find the different combinations, get a sum and a min, and put them on the heap. At the end, we just pull whatever's on top of the heap and return that. Since Python only does min heaps, we'll just multiply the value by -1, and whatever's the lowest is actually the highest after we multiply it back. So thanks for joining me. See ya.